Alright, what I'm going to do in this video is just a real quick recap of the properties of a quadratic function. So we know that anytime we have a function that looks something like this, y equals x squared, we're going to end up with a graph that we call a parabola. And the shape looks like a U. Okay, it's a little bit more pointy, but this is the basic idea. So there are a couple of things that we can look at for this. One of the first properties that you look at for any graph is the domain of that graph. Now, the domain is just another way of saying which x values are included in this graph. Okay, so if I plug an x value in, will it give me a point on the graph? Now, one nice thing about parabolas is that the domain is the same for all of them. It's always negative infinity to positive infinity. Or you could also say it's all real numbers. That's what this little r means with two vertical pieces there. Basically what I'm saying is no matter how far out I go on this axis, I can always plug an x value in and get a y value. So let's look at one that wouldn't have a domain that's all real numbers. If we had something like this, let's see, if we just had a circle. Now there's an equation that will give us that as our graph, a circle, okay? If we look at the domain for this, it would only be the x values that are included from here to here. If I plug in an x value over here, there isn't a y value to go with it, so then it's not included in our domain. If we look back at our parabola, no matter how far we go either way, we know these lines continue on for forever, so that means that all x values would be in our domain. Now the second thing is the range. Now the range is the y values. Since the domain was x values, now the range is the y values. So what we do is we look at the lowest y value that our graph goes to, and you can sort of trace your graph, and once you get to the vertex, this lowest point here, check and see what your y value is. In this case, the y value is 0. For just the plain graph x squared, the lowest y value is 0. That means that the lower end of our range is 0. For the upper end, we look at how high up can we go, and if I trace this out, well, this arrow tells me it's going to keep on going forever. So that means that I'm never going to actually reach a maximum y value. So for the upper end of my range, it'll be infinity. Okay, being able to label the vertex is important, and you can do that with an ordered pair. In this case, our vertex is at the point 0, 0, which is right here. And so we just write it as an ordered pair, 0, 0. Remember, the x-axis is this horizontal axis, and the y-axis is this one up here. We also have an interval of increase and decrease. So the interval of increase, if I'm tracing this graph out from left to right, the interval of increase will be the x values for which my graph is going up, for which my y values are getting higher each time I move to the right. Now the way I do this is I always just find my vertex first, because I know that's going to be where it turns. It's either going to go from increasing to decreasing or from decreasing to increasing. In this case, my vertex is at 0, 0, and so that divides it into this left side over here and the right side. So I have to decide which of these two sides is the increasing side. If I look at the left side here, as I trace this from left to right, my y values go down. They get smaller. That means this is my decreasing interval. Okay? That means the other side over here is the increasing interval. Now to write the increasing interval, I need to look at the x values involved here. So my first x value is 0. The x-coordinate of your vertex is always going to be basically important for these two intervals. Okay? So we've got 0, and then if it's on the right side, that means that if I keep going forever, the x value that I'm approaching is positive infinity. Okay. The interval of decrease is the opposite. It's on the other side. We go from negative infinity way out here to 0. That's when it turns around. Now we can do the x-intercept and the y-intercept. This is just where it crosses the x-axis. This is where it crosses the y-axis. For this one, it crosses the x-axis, or touches it at least, right here at 0, 0. Remember that both our x-intercept and the y-intercept have to be an ordered pair. So 0, 0. For the y-intercept, it actually ends up being the same for this one. We cross right here at 0, 0 on the y-axis. So again, it's 0, 0. Okay, there's one more last thing, and this one's pretty much the easiest one to decide. We have to determine whether the vertex is a maximum or a minimum. If it's a maximum, then it's the highest point on our graph. If it's a minimum, it's the lowest point. In this case, we've got a low point right here for the vertex. So that means that this is a minimum. Okay, extrema, and it is a minimum. All right, so those are the basic properties of a quadratic that you'll need to know, and that hopefully you can remember as we go through and look at other functions throughout the semester, so then we can kind of decide how it compares to a parabola.